This is Sung, and I'm the Principal and Director of Sky Academy. And in this episode, what I want to be doing is continuing on with our look into probability, and we want to be looking at successive outcomes. So up until now, we've just been looking at single stage probability. So in other words, probability that has to do with one event occurring, okay, or the possibility of one event occurring, the probability of one event occurring. In this episode, we'll be looking at a multi-stage event, or another way of saying it is successive outcomes, okay? So this is basically when you have two events, two or more, I should add, two or more events occurring in different stages, each with their own possible outcomes and possibilities, or probabilities, sorry, that should be probabilities. So successive outcomes are when you have two events occurring in different stages, each with their own possible outcomes and probabilities, okay? So for example, a classic example is tossing a coin, all right? If you toss one coin, it's either going to be a heads or a tails, right? So to add a little bit more complexity into the mix, what you can do is toss two coins or three coins, all right? In this particular example, we're going to toss three coins, or toss the same coin three times, which has the same effect, okay? Now, when coming across questions like this, all right, the easiest way to go about doing it is using what we call tree diagrams. And I want you to become familiar with tree diagrams because it's going to become a very often used strategy with probability, okay? So in this particular example, tossing a coin three times, what happens is basically you've got your first toss, second toss, and then you've got your third toss, okay? So let's see how it would work. Your first toss is either going to be a head or a tail. Your second toss is either going to be a head or a tail as well. And your third toss is going to be a head or a tail as well. And so that will be the tree diagram for a multi-stage coin toss, a three-stage coin toss. This stage will basically be your head or your tail, all right? This stage gets a little bit more complex. You either got a head or a head or a head or a tail, or a tail or a head, or a tail or a tail, and then you got the same thing happening with your third toss as well, okay? Now, what I want to do is show you that the first outcome that you can have is not simply just a head or a tail, it's going to be head, head, head. That's going to be your first outcome, okay? Your second outcome is going to be head, head, tail. Got that? Your third outcome will be head, tail, head, followed by head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. So, even though one coin toss will give you two outcomes, by the time you get to three tosses, you've basically got 8 outcomes. Got that? So with each coin toss, you're doubling the amount of outcomes that you can get. Okay? Now, the other thing that I want to mention is, what is the probability of tossing a head? It's 1 out of 5. It's 1 out of 2, right? So it's, or another way you can say it is 0.5. Okay? It's a half. What's the probability of tossing a tail? It's a half as well. Okay? What's the probability of tossing a head? 0.5, 0.5. Yes? And that'll be the same all the way across. 0.5, 0.5. And I wish I were a cooking show, because then I'd have something that I'd prepared earlier. Alright, here we go. So you've got 0.5, 0.5. All the probabilities are 0.5, right? Okay? Now, what's the probability of getting 3 heads in a row? What you've got to do is employ what we call the multiplication principle. All right? The multiplication principle says this: as you go across the branches to get the probability of that outcome, you multiply the probabilities. Okay? This times this times this gives you, what's a half of a half of a half? All right? It's 0.125 or 1 over 8. And what would the probability of getting a head, head, tail? It would be 1 out of 8 as well. What's the probability of getting a head, tail, head? 1 out of 8. Probability of head, tail, tail? 1 out of 8. All these probabilities will be 1 out of 8. As a decimal, it will be 0.25. What do you think the probability will be of adding up all of these outcomes? The probabilities of all these outcomes. Well, you've got 1, 2, 3, 4, 5, 6, 7, 8 outcomes, each with their probability of 1 out of 8. So in other words, the probability of the whole lot will be 8 out of 8, which is 1 whole. So this is basically how to do a probability tree for successive outcomes. All right. The sort of questions that you're going to be asked, though, are going to be like this. What is the probability that you can toss 2 heads and 1 tail? In which case, you would look for all the possibilities where you've got 2 heads and 1 tail. All right. So you've got 2 heads and 1 tail would be this one over here. 2 heads and 1 tail would be this one over here. 2 heads and 1 tail would be this one over here as well. So what would be the probability of tossing 3 coins that you have so that you have 2 heads and 1 tail? It would be 1 out of 8, 1 out of 8, and 1 out of 8. What would you do with these 3? Well, we know that they're mutually exclusive events, so all we'd have to do is add them together. 1 out of 8 plus 1 out of 8 plus 1 out of 8, which is 3 out of 8. Sometimes you might be given questions like, what is the probability that you have at least 2 heads? In which case, you've got this where you've got 2 heads, this one where you've got 2 heads, this one where you've got 2 heads, and this one where you've got more than 2 heads. In which case, what you can do is add 1 more 1/8, which you end up with 1/2 then, all right? 4/8, which is 1/2. So these are the type of questions that you might get, all right? So you need to be good at drawing tree diagrams. Let's have a look at another one, rolling a die and tossing a coin, okay? So if you roll a die, what are die or dice? Okay, it's up to you which one you say, but I like to say rolling a die. So if you roll a die, all right, how many different outcomes can you have, or how many different possibilities can you have? All right, you can have 6. Yeah, you can either roll a 1, 2, 3, 4, 5. You can roll a 1, 2, 3, 4, 5, or 6. Yes, and each of those can either be split up into head or tails, in which case your first outcome will be 1 and heads, 1 and tails, 2 and heads, 2 and tails, 3 and heads, 3 and tails, etc. Got it? Okay. What would the probability of each one of these be? You got 6 numbers, so each probability would be 1 out of 6. Does that make sense? And each of these probabilities will be 1 out of 2. So the probability of rolling a 1 and a heads will be 1 out of 6 times 1 out of 2, because we're going to employ what we call the multiplication principle. So it's 1 out of 6 times 1 out of 2, which is 1 out of 12, right? And you will find that because we've got 12 outcomes here, each of those will have a probability of 1 out of 12, okay? So in other words, if we were to be asked a question, what is the probability of rolling a number bigger than 2 with tails? What you would do is look for all the numbers bigger than 2 with the tails, all right? 3 is bigger than 2, and it's got a tails. 4 is bigger than 2 with the tails. 5 is bigger than 2 with the tail. 6 is bigger than 2 with a tail. So what you would do then is employ the addition principle, which is adding them up. 1 out of 12 plus 1 out of 12 plus 1 out of 12 plus 1 out of 12. All of that together gives you 4 out of 12. Okay? So just to summarize, as you go across the branches to get to an outcome, you multiply the probabilities together. As you combine the probabilities of the outcomes to get the probability of a number of events, you add the probabilities. Okay? So going across, you multiply. Going down, you add. Okay? And that's basically how the probability of successive events goes. All right. In the next episode, we'll be getting a little bit deeper into successive outcomes because it does get a little bit more complicated than that. But this is a good introduction, at least for the time being. All right. So thank you very much for watching.